All right, so we're in example 3 in solving a radical equation from section 1.4, and we're going to be using the power principle, that's why it's up there, to tackle this problem. And I'll show where it comes into play in a moment. I won't get into the power principle yet. Let's just try to tackle example 3, at least as far as we can go. So I'll let you know that if we have a radical equation, which means that we have a variable term under this under the radical, that in this case the square root, but it could be a third root or so forth. Realize that that we want to isolate the radical on one side of the equation. So in this case, we want to divide by 2. We want to divide by 2. I'll just divide by 2 right now. And when we do this, the 2 on the left side of the equation cancels, and we're just left with a radical. And this gives us x plus 1 divided by 2. Okay, and at this point, we have just a square root of something equals the right side of the equation. And this is where the power principle comes in. So the idea is we want to get rid of the square root on the left side of the equation. The way to get rid of a square root, to essentially cancel the square root, is to square that side of the equation. So if I was to square this side of the equation, the square root and the square would just kind of counteract each other. But we can't just square the left side of the equation. We also have to square the right side of the equation. So the power principle is similar to the other equality principles that we dealt with earlier in the term, the addition and subtraction equality principle and the multiplication and division equality principle that we dealt with earlier in the section. The idea is what you do to one side, add, subtract, multiply, or divide, you must do the same exact thing to the other side of the equation. So if, for example, if I was to add 2 over here, I would have to also add 2 over here. If I was to multiply by 3 over here, I would also have to multiply by 3 over here. So now we get into exponents. So if I square this side of the equation, I also have to square this side of the equation. Keep that in mind. It's important to realize that that we can also apply this with exponents. The equality principle. Okay, so what we notice is the square root cancels that with the square, and we get 3x minus 2 is equal to, and now we want to square the side of the equation, so we would square the x plus 1 and square the 2, and that gives us x squared, and then when you multiply this out, you'll end up getting, remember, just a note, this x plus 1 squared is x plus 1 times x plus 1. If you were to multiply this out, you would get x squared plus 2x plus 1 when you simplify it. And that's divided by 2 squared, which is 4. Now we can make this a little bit easier on ourselves and multiply both sides of the equation by 4. And that will clear the fraction on the right side of the equation. And we want to distribute the 4, so that would be 12x minus 8 is equal to x squared plus 2x plus 1. And then we want to, now notice we have a quadratic, so we want to get it in standard form, which I'll do up here. So that is x squared plus, so I would subtract 12x, so that would be minus 14x, or sorry, that's minus 10x. And then add 8, we get 9 is equal to 0. And notice that 9, so we want to factor this, so notice 9 will factor to -9 and -1, and that will add up to -10. So this will give us x minus 9, x minus 1 is equal to 0. And then we can break this into x minus 9 equals 0, and x minus 1 equals 0. So we get x equals 9 and x equals 1. So two different solutions. Now, you want to keep in mind that, and this is really important, this is not an option at this point. When you're dealing with radical equations and you're solving radical equations, you always check. So emphasize, I'll put it in, I don't quite have a red color. That's a burnt red. But I'll just say always check your work. Always check. Okay, so I'm going to check and plug it into your original equation. So we have 2 square root of 3 times 9, and that's subtract 2, and that's equal, and we want this to be equal to the right side of the equation, which is 9 plus 1, and so that would be 2 times, so that's 27 minus 2 is 25, so that's the square root of 25, and we want that to equal 10, 9 plus 1, and square root of 25 is 5, so 2 times 5, that's equal to 10. Good, it checks. So x equals 9 is a solution. Okay, now 1. 2 square root of 3 times 1 minus 2 is equal to 1 plus 1. Hopefully. We're not sure yet. 3 times 1 is 3. Minus 2 is 1. So that's 2 times the square root of 1. Is that equal to 2? And we'll notice that that's 2 times 1 is equal to 2. Good. So that is also a solution. Okay, so you always want to check your solutions, and if we happen to have a one of these two solutions that did not check out, that didn't mean you did something wrong. You just have to cross out that solution, and you may only have one of two solutions, or so just check your solutions and see if they make sense. All right, let me know if you have any concerns about solving radical equations.